Welcome to The Explainer. Today, we're decoding the mind of an absolute software legend. We're looking at how Anders Hejlsberg tackles massive engineering crises. And spoiler alert, he does it by prioritizing developer productivity way above academic theory. If you've ever written a line of C# or TypeScript, well, you've lived in his world. So let's unpack exactly how this guy thinks.
Okay, let's dive into this by rewinding to the pre-1996 era. Think Turbo Pascal and Delphi. Hejlsberg really built his reputation here on two main things: blazingly fast development and incredibly strong tooling. And you know what? Those early values of rapid compilation and readable syntax, they didn't just fade away. When he joined Microsoft in '96, spearheaded C# in the late '90s, and then went on to build TypeScript in the 2010s, that exact same DNA carried right forward. He isn't an academic theorist sitting in an ivory tower. He's a pragmatic engineer who builds tools for everyday engineers.
Here's our roadmap for The Explainer. We'll start with the pragmatic architect, look at designing C# for reality, tackle the JavaScript scaling crisis, explore why tooling is the language, and finally wrap up with the art of trade-offs.
All right, Section 1, the pragmatic architect and the mandate to make developers productive.
I want you to think of Hejlsberg not just as a coder, but kind of like a city planner for software ecosystems. His absolute #1 focus is large-scale maintainability. He isn't trying to invent some exotic, minimalist language that looks gorgeous on a whiteboard but is completely impossible to use in production. No, he wants to build robust infrastructure where literally millions of people can collaborate without the whole thing collapsing. And his famous guiding question? What helps millions of developers build large systems safely without slowing them down? This one question completely replaces the desire for mathematical language perfection with a relentless drive to reduce developer pain.
Let's move to Section 2 and see how this builds into designing C# for reality, specifically looking at the massive crisis of the late '90s. To really appreciate C#, we have to talk about the villains of the era, the immense friction developers faced back in the late 1990s. We're talking memory corruption, header hell, incredibly complex ABI issues, and tooling that was just plain difficult to use. If you actually lived through it, you know exactly what I'm talking about. The software mess was terrifyingly real, and it was literally slowing businesses to a crawl. Microsoft realized they desperately needed a managed runtime where developers could just be productive again.
Because at the time, the industry was basically torn between two extremes. On one hand, you had C++, which gave you incredible, raw power, but it came with a whole host of nightmares like memory corruption, dangling pointers, and memory leaks. On the other hand, you had Java. Java was safe, sure, but you sacrificed a ton of that systems-level flexibility. C# was designed to step right into this massive gap. The goal was absolutely huge. Give developers the raw power of C++, but combine it with the safety of Java and the rapid productivity of Visual Basic.
Now, what's really interesting about this basic C# syntax is how unremarkable it looks. If statements, for loops, class declarations. Hejlsberg intentionally made C# look and feel super familiar to C, C++, and Java developers. Why do that? Because it proves his whole philosophy of valuing familiarity over novelty. He absolutely did not want developers to have to relearn all their hard-earned muscle memory. Lowering the friction for enterprise adoption was absolutely crucial to the language taking off.
But, he also understood that developers sometimes hit a brick wall and just need raw power. Using an unsafe block to access pointers directly brilliantly illustrates his non-ideological approach. C# is a managed, garbage-collected language. It's incredibly safe by default, but it deliberately gives you these escape hatches for systems-level power when you really, truly need it. It's practical, not dogmatic. Okay, Section 3, the JavaScript scaling crisis and how to fix the ecosystem.
Fast forward to the 2010s, and JavaScript completely dominates the web. But that explosive growth, it created a massive new engineering nightmare. Just imagine the absolute pain of managing huge, brittle JavaScript projects back then. Large apps became incredibly hard to maintain, terrifying to refactor, highly error-prone, and weakly structured. Microsoft was actually feeling this exact pain internally with their own massive applications. But Hejlsberg knew JavaScript wasn't going anywhere. He had to find a non-disruptive solution that didn't mean throwing the entire web ecosystem in the trash.
The solution to that crisis was TypeScript, and it hinged heavily on the concept of writing something as simple as let x:any. This represents gradual typing. Instead of forcing immediate, rigid strictness on a project from day one, developers could adopt typing incrementally. This meant those huge, existing JavaScript projects could slowly migrate over to TypeScript without breaking their entire ecosystem overnight. A real game changer. So, The crucial point is how this type system actually behaves. C# uses a rigid nominal typing system, but for TypeScript, Hejlsberg went with structural typing. As defined, compatibility is determined by the actual shape or structure of the data. Basically, if an object has the right properties, it's accepted. Instead of forcing a rigid system onto the web, he brilliantly adopted the type system to perfectly match JavaScript's dynamic nature and respect how developers were already writing their code.
Moving on to Section 4, tooling is the language. The IDE and compiler acting as one.
This brings us to one of Hejlsberg's absolute most important conceptual pillars. You simply cannot separate the language from the developer's working environment. Calling TypeScript a tooling platform disguised as a language is honestly such a profound way to look at it. It's not just syntax, it's a powerful engine designed specifically to power your editor. This directly bridges his early work in Delphi, which was legendary for its rapid feedback, all the way to modern developer environments like VS Code.
With deep integrations like autocomplete, rename refactoring, safe API discovery, rich diagnostics, and static analysis, the compiler's understanding of your intent becomes just as much a part of the language as the syntax itself. This is huge. The reason those massive JavaScript codebases finally became manageable was specifically because the tooling could accurately analyze them and help developers navigate the code safely.
And finally, Section 5, the art of trade-offs, prioritizing practicality over purity.
When we synthesize his approach, we see exactly how Hejlsberg constantly balances extremes to create long-lasting industry standards rather than just academic curiosities. Safety versus productivity, he balances them. Strictness versus flexibility, he makes strictness optional. Simplicity versus power, he uses what he calls gradual complexity. Gradual complexity is brilliant because it allows beginners to start simply, but the language scales up to handle incredibly advanced systems when you need it to. It's the ultimate pragmatic trade-off.
And this brilliantly illustrates the connection between his two masterpieces. When you look at the design aspects of C# and TypeScript side by side, it's pretty amazing. Despite operating in totally different runtimes and eras, they share the exact same underlying DNA. They both aim for managed productivity. They both heavily prioritize compatibility with existing systems. And their migration paths, fundamentally easier than the alternatives of their time.
Which brings us to the core truth behind his massive, industry-defining success: respect for the ecosystem. Anders Hejlsberg doesn't design programming languages to impress language theorists. He designs them to help millions of developers build massive software systems more safely, productively, and sustainably. C# and TypeScript succeeded not because they were radical, but because they respected developers, they respected existing ecosystems, and they respected the realities of software engineering.
So, I want to leave you with this provocative thought. If the architect of modern programming prioritizes practicality over purity, should we be doing the exact same thing in our own code? Next time you find yourself debating the most mathematically elegant way to write a function, maybe ask yourself if it actually reduces friction for your team. Thank you so much for joining me on this explainer. Keep learning, stay pragmatic, and I'll catch you next time.